It is 2 hours UTC, and it's time again for Astronomy Daily Live. So, hey, everybody. Come on in. Come on in. I've got the chat up and running here somewhere. There I am. There it is. So, come on in. Usually takes a couple minutes for everybody to assemble into this circle of friends who come together every single day and talk astronomical things. Hey there, Uncle Bill. Nice to see you in the chat again. Cheers. I do have the hydrogen hydroxide again. Cheers. So, hope everybody's doing well. Welcome to those who are coming in. Welcome to those who are going to be seeing this later. Glad you could come in. Make sure, to share this around if you think anybody else may have an interest in this kind of stuff. This is astronomy, but it's sort of presented in a different kind of a format, right? So instead of interviews and sort of talking at you, I'm just sort of the host, and we just sort of go along this journey together. Hey there, Atta, you are here tonight. So yeah, we just had at 0 hours UTC every Monday at 0 hours UTC, we sort of have a midnight movie, right? Or a midnight show of some sort. And so just got off of that. Bobby was in it. Actually, Bobby's on the panel again. Hey, Bobby, what's up?
Nothing much here.
Okay. Everything's good here. Everybody, let me know if the audio is okay. All of that. I've switched again to Linux machine number one. Linux machine number one, which is sort of my primary machine, because I know that the audio and everything works. And obviously, Bobby's on the panel. I can hear you well. Yeah, so I think that's going to work. As you can see, I'm back to this too. Hopefully, this fan noise isn't too annoying. Through this mic, I'm not sure if you'll be able to hear it or not. But anyway, so yeah, I since when I started this live stream last January, I thought that I looked around and I couldn't see that Chrome was running on Linux. Now, I could be completely wrong, which is why I went to a Windows 7 machine, because I knew, that Chrome was on there, and you apparently have to run Google Hangouts on Google Chrome. At least that's my understanding. Okay, cool. Hey, Andy Cowley, nice to see you in the chat again. Thanks for coming in.
And speaking of Chrome, I got on my Ubuntu system, and Google Hangouts runs pretty darn well. It's the same download page as if you were downloading from Windows or Mac.
Yes, yeah, it actually seems to sort of detect what OS you have. So yeah, I just downloaded the RPM file and did an installation, and easy peasy. So yeah, no problem at all. If I can run it on this machine, I think we should be good. Actually, I'm going to start up my my smartphone so I can sort of monitor the live stream, make sure that I'm not freezing up or anything, although you guys are really, really good at letting me know that. But I will start that up, and I'm got to mute it. It looks like looks like it is running okay. Hey there, Tom. Nice to see you. Anyway, so yeah, as I was saying, 0 hours UTC every Monday. I try to do some kind of midnight show. And today was Star Trek, the original series, an episode, probably one of my favorites. I would say definitely in my top 10, maybe top 5. Have to think about that. Called the Tholian Web. And I think the thing that I like most about that episode is that it's really busy, right? There's like lots of problems to be solved at the same time. The entire crew is going insane, right? Kirk is missing in some kind of weird spatial thing, going between universes. In fact, they talk about on the multiverse, which if you're into those kinds of things, then it's pretty good. Spock seems to know a lot about it. So he's seen very authoritative in terms of how multiverses interact with one another and all that. And you have these aliens who are like, "What are you doing here? Get out! And if you don't get out, we're going to grab you and take you away." So yeah. So there were like three things going on at the same time. So it's a very busy episode. I thought the acting in this one is really, really, really great. Spock has some great lines, really great lines, and I've observed that really good episodes, at least for part of the episode, Scotty has the con, and that when Scotty has the con, that things are going to get done, and they're going to get done right. so yeah, very, very cool. Good episode. So yeah, as I said, that happens every single Monday at 0 hours UTC. So come on in if you haven't gotten onto my rabbit room, I guess you call it. Do so. I think there's a link in the description below, and if not, maybe I will post it now. And last night, Bobby played the most recent, I called it Rabbit, RABB.IT. Bobby played the latest Hearts of Space episode, which was very, very good. Very, very awesome. So here, I'll post a link to my profile page. I think from there you can get in. So I'll just post that on the chat. Paste. Okay, the YouTube channel Joe Collins uses the proprietary Chrome. Oh, okay. Interesting. I'll have to check that out also, Uncle Bill. Yeah, you seem to always find some pretty cool things. So yeah, come on in, friends. Join in a circle here. Maybe.
Now, when you get either Debian or the Red Hat package, it should automatically install a repo. So when there is a new update, you should be able to get it on the spot.
Okay, cool. Yeah, I've got Fedora here, and yeah, I mean, obviously it's running just fine. So, all right, very, very cool. Well, I wanted to do a little bit of follow-up from yesterday's live stream. We were talking about Messier 25. And I realized after the live stream that one of the things that we did, right, is we looked at a paper about one of the stars in there having very, very strong, unusually strong magnetic fields. It turned out to be a spectroscopic binary system and all that. And I realized after the stream, it's like, which star was it? So I thought that I would sort of start there, and then I was also talking about possibly being, if somebody was interested, you could probably go over to the GAIA archive, grab those stars in the region, well, the stars in that region, and look at the proper motions, and actually probably be able to pick out members of the cluster. So I thought that we would try to do that tonight. Do some sort of simple astronomy on the fly. So where else are you going to see that? Okay. So cheers. Not prepared, haven't looked, have no idea what to expect at all. This is a lot of what astronomers do, is like, okay, let's dive in and take a look, see what happens. So I can do all of that on this Linux machine because, as I said, this is sort of my primary one. It's the one I work with most of the time, so I can plot things. I can, just the whole thing. So we'll see how we do there. So I think the first thing that I want to do is just sort of show you which star that was that we were talking about yesterday. And so I'm going to show my Google, I'm going to share my Google Chrome, maybe. All right. So we'll go over here to Google Chrome. And so this is off of Simbad, of course. Oh, it's running a little slow. Poor thing's having to work pretty hard. I'm going to get rid of some of these windows. I'm going to get rid of that one. Ah, poor machine. I'm going to work a little hard here. It's keeping up, though. Come on. And I'm going to get rid of that one. Uh-oh. There we go. Let's get rid of this one. Junk. You're going to let me? Come on. And I'm actually going to get rid of that one, too. And I can get, actually I can get rid of all of these tabs up here. So be a little bit patient while I deal with the technology here. I think I can get rid of, this one. Get rid of that one. And I can get rid of that one. It's being a little slow, but that's all right. In astronomy, you have to be patient. If you're not patient and persistent, forget it. Anyway, so as you can see on the screen here is M25 again. And this is just a open cluster, but it happens to be right in the galactic plane. So there's a lot of background stars, and most of the bright ones that you see here are probably associated with this cluster. But maybe these over here, I don't know. Anyway, the star that we were looking at last night with the strong magnetic field is actually this one right there. So I'm going to put him in the center. Maybe. It's thinking about it. Oh, I don't have any background music. Yeah, okay, well, that's not going to happen, I guess. Not with the microphone. Oh, well. Let's see. Whoop. Okay, so he's acting really, really, really slow. But we will be infinitely patient. Come on. Okay, now I'm going to zoom in. It's going to be a little bit slow. So I either have to deal with a slow machine or a mute and silent machine. That's not a good choice. Not a good choice at all. Well,
You definitely try to get like one of the bikes, like those $100 machines.
Yeah. Yeah. Anyway, there's the star right there that they were studying, that one right in the crosshairs there. So yeah, I thought about that afterwards. It's like, well, which star was it? So there it is. There it is. I'm going to reload my live stream on my smartphone here just because it's being a pain. There we go. Okay. All right. So yeah, I thought what I would do tonight is actually go into the GAIA archive and see if we couldn't maybe identify some of the stars as members just by their motion, right? Because they're all going to be moving about the same. All these other stars in the background aren't going to be moving like those that are members of the cluster. I don't know if there's going to be much of a difference, but I think there should be. So I'm going to kill this tab too, and that'll bring us over to the GAIA archive. And oh, actually, you know what? I need another tab. I just killed that tab, but I'll start a new one because what we need to do is we need to look up M25 because for GAIA, I need to give it a celestial coordinates. I'm going to check my my chat here. Yeah, you know what? I need to look into chromium too. Yeah, no problem. No problem. All right, so let's go over to Simbad. And this is going to be a little slow. I have typed in the word Simbad. There we go. Well, we've got to deal with a little bit of slowness. That's all right. We can deal. As I said, in order to be an astronomer, you have to be pretty patient. You got to be patient with things, and you have to be patient with yourself. I think that doesn't necessarily only apply to astronomers either. So I've typed in Messier 25. There it is. And we'll select that. Just going to get the right ascension and declination of this guy so we can punch it into GAIA. I guess I also want to get an approximate size because GAIA wants like a radius. Okay, so...
Well, getting yourself a new machine, I think the Windows times are usually better. But if you get like a Chromebook, you're going to have to modify it so you can have your Stellarium, your Chromium, your Chrome, whatever.
Yeah, I think any kind of upgrade at this point would probably be an improvement for sure. Okay, so we got a right ascension of 1831. I think I can, let's see if I can just, wow, this thing is running really slow. 1831.47. I've highlighted that, but it's, there we go. Thing. Okay, copy. So here's the Gaia archive, and this is the main page. If you haven't seen this yet, I like to start things, you know, from where you would start. So this is the main page, right? In order to search for things, I just hit search. Seems logical. So then you get this this screen, which I'm going to choose equatorial coordinates here. So this should change to an RA and a deck eventually. There it goes. Okay, so now I can paste in my RA, and these guys are clever. They if the coordinates are acceptable, then that R and A there will turn green, as if it's like, yep, we're all go on RA. So I think, have I? No, I guess I have it. So I think I can just do this. Paste it in there. And let's see if it turns green. Did it turn green? I don't see it turning green yet. If it doesn't like it, it should turn red. But this poor machine is really working here. Huh, I'm not seeing it change. So I'm going to go over here and grab the deck, and then we can deal with if anything goes red, because we need to see about how big this thing is too, because you can see on the right there. Okay, so this thing is not giving me a size, so we're going to have to guess. Okay, so let's go negative 190700. I've highlighted that. Come on, there you go. Good job, machine. Okay, so I've copied that. I'm going to go over here again. Maybe it's turned green by now. I don't see it red or green there, so I'm just going to go with it. And let's do, I don't know. Let's do, let's make a radius of, let's make it the size of the moon. So we'll make a radius of 15 arc minutes. I'm going to change that 5 to a 15, which I've already done. And I'm going to change this unit from arc seconds to arc minutes. Should give me that option here. There we go, arc minutes. So we're definitely going to search in the GAIA data release 2, so we don't have to do anything there. I think I am going to apply some extra conditions. I think I'm going to limit the magnitude, the brightness of the stars, because otherwise it's going to pull out every single star down to like 23rd magnitude, which we just don't need. I think if we look at everything, maybe, I don't know, let's do 16th magnitude or brighter. Okay, so we're going to choose from this list, which is going to be fun to scroll down because it's so slow. We'll get there. Let's see. Looking for Phot G mean mag. There it is. Let me make sure that I'm... Yep, okay, so let's select that. And that should change here. Okay, and so we want Phot G mean mag to be, we want it to be brighter than 15th. So in astronomy, the magnitude scale, the brightness scale is sort of reversed, right? The smaller the number, the brighter the object. So I need to make that a less than or equal to. And then this is almost agonizingly slow, but I think we're a bit too casual and fun here to worry about that kind of stuff. It's just a little bit annoying. Okay, so there's that. So now let's grab just certain pieces of information. This is going to pop up a big window showing all the possible pieces of information available in the GAIA Data Release 2 archive. And as you can see, some things are chosen by default. And I'm going to scroll down here slowly. So quite a bit of information, right? That's why a lot of papers that we're seeing coming out of archive.org reference GAIA, because there's so many ways of looking at all this data, right? So it's very cool. Okay, so I definitely want the RA and DEC, right? Oh, let's get this whole box in here. Okay, so we definitely want the RA and DEC. Source ID is nice. Oh, I think I scrolled a little bit too far. But this RA error and DEC error, we don't need that. So once this thing has decided to do that, I think I can uncheck that. I'll check my chat really quick. Yeah, this Uncle Bill, this is a fresh Chrome. I just started it to start up the live stream. Let's see. Yeah, it's possible. I don't know how much memory I've got in here, but it isn't any more than 8. I know that. Okay, so the RA error is done. The DEC error, well, let's get rid of that. We don't need parallax. We don't need parallax error. But we do want proper motion of RA and proper motion in DEC, because that's obviously the motion of these objects. Let's make sure those are checked. Don't really think, radial velocity might be useful too. So let's keep that in there. That of course is how fast it is moving relative to us in sort of a radial way, sort of a distance thing. But I can turn that off. I can turn that off. I can turn that off. I definitely, though, want the magnitude, right? Because I'm gonna make a plot that actually shows the stars, sort of like a finder chart. We definitely want that. So I think that's all set, right? Source ID, RA deck, proper motion in RA and deck, magnitude. We don't need that. BP, huh? Not quite sure what BP is. Radial velocity, yeah. Okay, everything else is turned off. So okay, let's. So I think down here, what I like to do, because I'm a database guy, I like to actually see the query before I send it off to the archive. So come on, you got to scroll down. You can do it. I know you can. Okay, so let's show the query. I'm sort of glad, in a certain sense, that it seems to be making the stream sort of a priority and slowing everything else down. So that's good. I think the only thing I'm going to change here is the number of objects. See, so right now the query is just going to pick the first 500, and there may be more than 500 stars in this list. So I'm just going to make this like an insanely large number, like 500,000. Now, there is definitely not going to be 500,000, right? But I want to get them all. So once that's done, I can submit the query. Everything else looks good, right? Here's my G magnitude less than or equal to 15. Here's the RA in degrees. Here is the deck in degrees. And here is the radius in degrees. So let's do it. Hit the submit query button, and we should see a little thing down here eventually. Here we go. It's working. And when it's finished, I think this will turn to a checkbox, and we'll have a number of rows here, which is the number of targets it actually found. Then we can start plotting. So this is just grabbing our data. So the whole point again is to see if we can look at all the stars in the region of and including M25, and see if we can identify by their motions the members of these stars. Okay, so now you can see that it seems to have finished, and it's found 1,367 objects. Very cool. That's a pretty nice, rich field. So now I'm going to change this to a CSV file. So that's just a text file with each column separated by a comma. And so then I'm going to download it using this option right there. Hopefully the plotting will go a little bit faster. It should. Oh, did it do it already? I guess it must have done it already. Okay.
Yes.
Okay, cool. So now what I need to do is I need to switch screens on you. So I'm going to stop sharing this screen. And I'm going to share. I'm going to look at my chat really quick just to see. Yeah. I'm a big fan of RAM too, for sure. But it surely doesn't show. Okay, for some reason that application window, I can't see it. So let me scooch it up here and see if I can see it now. I was able to see this before. Yeah, here we go. Oh, you know what? I think I do want to just share my whole screen because I'm going to be going all over the place. Okay, so I'm going to go here. And I can make that really big if we want. Hide that. Make sure I'm sort of looking on my smartphone here to make sure that we're good. So this is just a Linux terminal, right? So I think in downloads, I'm gonna put you down just for a sec. Let's find out where it put it. Show in folder. Home downloads. Oh, it did put it in downloads. Huh. Why didn't I see it there? There it is. Okay, so I've just copied this file, which I downloaded, into a new file. I just renamed it M25.csv. And we can look at this. And as you can see at the top, it gives a description of each of the columns and then just data. And there should be 1,368 lines because we've got all the data and our top line here. Whoop. Sorry about that. There we go. I don't know if you're hearing the sound effects or not, but yeah, that's my machine. So here is the source ID. Here's the RA in degrees, the DEC, the proper motion in RA, the proper motion in DEC, and the radial velocity. That's probably in kilometers per second, is my guess. And then, I'm not quite sure what this other column is. I don't know what this last column is. It's not going to matter. So just so we don't confuse GNU plot, I'm going to, oh, that's why, because I've got my caps on. Okay, let me, here we go. Okay. Just so GNU plot doesn't get confused. Oh, no. I'm sorry. This is the magnitude. This is the proper motion. So not all of them have, or I'm sorry, a radial velocity. So not all of them have a radial velocity measurement. Just some of them, right? They all have magnitudes. They all have proper motions. And of course, they all have positions. So, okay. So now let's get into GNU plot, which is absolutely fantastic plotting program. So first, what I want to do is I just want to make sort of a finder chart showing you the positions of all the stars and also their magnitudes, right? Their brightnesses. So what I need to do first is I first need to tell GNU plot that I'm going to separate my columns by commas. Set data file separator, and I'm going to say that it's going to be a comma. Okay. So now let's look at this again. M25. Okay, so I've got column 1, 2, 3, 4, 5, 6, and sometimes 7. Okay, so in this case, what I want to do is I want to use columns 2 and 3. That's going to be the RA and the deck. That's going to be the x-axis and the y-axis. And then I'm going to use column 1, 2, 3, 4, 5, 6 as my brightness. So I'm going to change the size of the dot depending on magnitude. So to do that, let's call them M25. So I'm going to use 2 and 3, and then it's going to be this funky little equation. Oh. So I think I'm going to have to, so 0.15, I've got to come back here and do that. So that just says to use the value of column 6, subtract it from 15, the number 15, and then multiply that result by 0.15. And that will give us a size. See, so if you do that for sort of the first one here, right, that would be 15 minus 10.118686 times 0.15. So that'll give a point size of 0.73. That might be a little bit too small. Let me do like a 0.5 just for starters here. Now let's see, did I do that right? I think I need to do one more here. Okay. The point type is going to be a circle, which is point type 7. The color is going to be black, and the point size is going to be variable. Variable. Let's see if I did all that right. Yeah, there we go. So those dots are a little big. Let's change this to maybe 0.25. There we go. And we need to actually flip this around. So let's go from, see, because this is going from a smaller RA to a larger RA. And that's not how it looks like in the sky, right? So let's flip this around, the x-axis around. So 278.3 to 277.6. I'm going to make that small again. Okay, so 278. Oh. Sorry, that's going to look kind of funny. 78.3. What was it? 277.6. 277.6. Okay, so now that's the right way around. And yeah, I recognize there's our magnetic star right in the center. Remember that? So yeah, so these are all the stars that are 15th magnitude or brighter. I can actually make that a little bigger if we want. So that's kind of a neat way to make a finer chart, and I think I've done this in the past on these live streams. So yeah, that's pretty good. So the idea here, right, is that the bigger dots are the brighter stars, and the fainter dot, or the smaller dots, are the fainter stars, and the smallest dots on here are 15th magnitude. The biggest ones on here, oh, I don't know. I have no idea how bright these are. I think this guy, our magnetic star, I think he was like 10th magnitude. So this is probably, I don't know, 6th or 7th. Not sure. Easy enough to find out if we want to. But really what I'm interested in is seeing, is now looking at the proper motions and seeing if there's a clumping. Because my guess is that any members of this cluster are basically going to be moving in the same way, right? They're going to be moving in the same direction at the same speed. And anything that isn't a part of this cluster is probably in the background, right? Because we're looking into the galactic disk. There's a lot of background stars. This cluster, didn't they say, was something like 620 parsecs? Is that right? Something like that. So pretty close relative to our background stars, which are going to be, you know, tens of thousands of light years away. So, yeah, their proper motions we're really barely even going to notice, right? But these members of the cluster, I think, should pop out. So I think what we should do, how do we want to do this? We've got proper motions here in RA and DEC. Why not, let's just, for starters, right, let's just plot RA proper motion along the x-axis and DEC motion along the y-axis and see what we get. I'm not quite sure what to expect there. So we'll let it auto range, telling it which file to look at, and we're going to use column 1, 2, 3, 4, and 5. 4 and 5. I'm not going to change the size of the dot. It's all going to be the same size. So it's still going to be a dot. We'll still make them black. And let's make a point size of, I don't know, 1. Okay, so in this list, there are some stars that are really moving fast, right? These guys over here are moving really, really fast. I dare say even this guy and this guy are moving pretty fast too. And there's a clump here of the rest of them. So kind of hard to see. Let's change the point size, about 1/10 of that size, and see if there's any. Okay, so I'm starting to see some clumping in here. Why not? You know, we sort of know that these outliers probably aren't going to be part of the cluster. They're going to be, you know, something else. So let's limit our view. Go from -20 to 20, and from negative, well, let's go -20 in both directions. So here I'm going to go -20 to +20, and here I'm going to go from -20 to +20. Okay, and it's a little bigger now. Oh, that's maybe a little bit too big. 0.5 maybe. Ooh, okay. So I am definitely seeing a clumping, right? There's a big concentration right there. Let's zoom in a little bit more. Let's go from -10 to +10 in both directions. Let's change that to a 10. Change that to a 10. That to a 10. And that to a 10. Ooh, nice. So a lot of the stars have sort of almost no proper motion at all, right? Or just a little bit. But that That right there is pretty interesting. Pretty interesting, right? So I think what we can do, is we can do a little bit of math here. What I want to do is I want to combine this motion, right? This RA motion and deck motion into a single value. So what I'm going to do is I'm going to square this one, add those squares, and then take the square root. That's Pythagoras' theorem. So let's do that. Now, I don't know what this is going to look like. So, I don't know. Okay, let's just do it. So let's see. It's going to be, and I think square root is possible here. So again, 1, 2, 3, 4, and 5. So number 4. Uh-oh. I'm going to square that times $4. And then I'm going to add that to $5 squared. $5. You following me there? Is that all right? So square root like that. Oh, I don't know what that's going to do. That may not be valid. Let's try it. Okay, so that's all of them. All right, so let's limit this again. So the x-axis now is going to be the object number, right? And there are like 1,367 of those. So we can go from 0 to 1,367 here. And let's go from -10 to, well, we don't really have to go any kind of negative because we're dealing with squares. So we'll just drop it a little bit. See, okay, see, so there are stars here that are coming up around, what is that, about 6-ish or so? See how there's a little bit of a clumping there? Everything else is pretty randomly dispersed. But there seems to be quite a number of stars that are sort of right around 6 or so. Let's go 0 to 10. It's not going to be quite as obvious, I don't think. Now, it's a little bit harder to see, but yeah, a little bit more than 6. You see the concentration there? So I'm thinking, and in fact, you know, I might be able to exaggerate that a little bit if I change the point size. Let's see. Sort of. Sort of. I kind of like this one more. This one. Kind of like that one more because it's really, really obvious that we're seeing a little bit of negative RA motion. You know, maybe 2 milliarcseconds per year in RA to the east, and about 6-ish milliarcseconds per year to the south. So this is a motion plot. It's not a position plot. You got to think in slightly different ways. There's some interesting structures here, you know, but it's really, really easy for our brains to see patterns, right? I mean, it's sort of like looking at clouds. You know, you start seeing all kinds of things in what really is just sort of a random distribution. But, you know, interesting interesting shapes, interesting little patterns. But I can definitely say, right, beyond a doubt, that there's a bunch of stars that are clumped right around there. Now, what we can do is we can add back in the magnitude, right? So let's do that. I can just copy and paste. Well, let me get rid of all of this, and then I can just copy and paste this. And so now we'll get exactly the same plot, but the size of the dot will correspond to the brightness of the star. And we'll probably have to change it a little bit, but let's see what this looks like. Interesting. Let's change that a little tiny bit. Oh, look at that. All the bright stars, most of the bright stars, there's a few that aren't moving much, but most of the bright stars are moving in pretty much exactly the same way, right? So here's a bright star over here that is moving completely differently, but I would say for sure that we are seeing members of that cluster, right? Because if we look again at the cluster itself, right, in the sky, which is that, right, we can sort of, oh, and, you know, let me get this to the same scale. Okay, so here's sort of the four brightest ones, right? 1, 2, 3, 4, more or less. And four brightest ones here. Ooh, those, they're just buried, right? Let's go from -5 to 5 in X. I'm going to narrow this down a little bit here. So -5 to 5, and let's go from -10 to 0. -10 to 0. There we go. So yeah, it looks like a lot of the brighter stars are definitely moving in that direction. Now, you know, another thing that we can do is we can actually go back to this terrible plot, and I'm going to have to stretch this out a little bit, because what I'm going to do is I'm going to let's see if this. Oh man, I don't know if this is going to work or not. What's that going to do? Oh, no, I don't think that's going to work. I was trying to see if I could make that plot show the magnitudes, but X. Oh, yeah. I think that should work. I think that should work, actually. No. Not what I was expecting. Let's see, how can I do that? Don't know how to do that. So we'll skip that for now. But yeah, it definitely looks like we've identified members of this cluster. These guys. Now, being able to go from, say, this. Is this our? No, that's not our position one. Our position one is this guy. So being able to say exactly which ones of these are members probably goes a little bit beyond the scope of what I wanted to show off here. Plus, I think I need to think about how to identify those. Yeah, I would. Don't know if I'd be able to do that necessarily inside a GNU plot, but we can definitely, for sure. Is it this one? Oh, oh, that's all messed up. Definitely, for sure, we've identified objects that are moving more or less the same. And as you can see, even some of these faint guys look like they're moving in the same way. Now let's really zoom in on this bad boy. Right? Let's go from -1 or -3 to -1, because I really want to dive into the middle here. -3 to -1, and we'll keep it square. So let's go. Let's see. This is a difference of 2. So let's go -7 to -5. -7 to -5. There we go. And we can actually see if this makes any kind of difference. So again, this is a proper motion plot, right? It's not a position plot. This is how these stars are moving in the sky. So these numbers here are milliarc seconds per year, right? So this star, right? This star, you can look at the coordinates here, right? And those are the numbers. So if I point to that star right there, okay, what that tells me is that that star is moving east in right ascension 1.5 milliarc seconds per year, and it's moving south in declination 5.6 arc seconds per year, right? So I hope that makes sense. This is not a position plot. This is a velocity plot. So yeah, I think you know, one would have to sort of decide where to draw the line, right, in terms of you know, which stars are moving and which stars aren't. But I would say, you know, at least right here, right, most of these stars are probably going to be associated with that cluster, right, for sure. Now we also have a radial velocity column, and I think that was column 7, right? 1, 2, 3, 4, 5, 6, 7. It's the last one. Let's just look at that really quick. So we don't have all of these, but we know that it's going, what, to 1367 of them. Keep that open. 25 using 7. And we'll just do a point size of 1. Just see what that looks like. Okay, so so there aren't very many radial velocity measurements here, and I'm looking at that and I'm not really seeing any kind of clumping. Not really. Let's change the scale a little bit. Sometimes you can play little tricks. Let your eyes see things that usually they can't. Oh, that's a little too small. Yeah, I'm not going to claim to be able to to see any kind of bunches of stars that are radially moving the same way. So, Gaia, you're not gonna be able to tell us that, at least not the way that I am looking at it here. Now, one of the fun things that one can do with GNU plot is you can actually plot things in 3 dimensions. So, and it can be any dimension you want, right? So let's just for fun, right? Let's plot proper motion RA, proper motion deck, and radial velocity. So X, Y, and Z. So that's 1, 2, 3, 4, 5, and 7. So there's going to be 3 of these. 5, using 4, 5, and 7. We can do the same thing here. Okay, so we got a little bit of a, that's right, we want to, let's limit this from -20 to 20. Let's go 10 to 10. We need to do that for first 2 for X and Y. We'll let the radial velocity float. Okay. So x-axis is proper motion in RA. Y-axis is the proper motion in DEC. And then the z-axis here is the radial velocity. And that's one of the cool things that you can do in GNU plot is you can rotate this thing around. And I think, you know, since we sort of know where to look, yeah, I'm still not really seeing anything there, right? There's a little bit of a clumping here, but if I look at RA and DEC, I guess that does, well, no, that doesn't really correspond to it. So yeah, using those 3 dimensions, not seeing it at all. I think really the best view that I've seen is this one. Yeah. So very cool, very cool. So what one would do after this is say, okay, I've identified these stars as sort of more or less moving in the same way, moving in the same speed, in the same direction, right? Their vectors, their velocity vectors are more or less the same. There's a spread, right? They're not all exactly the same. There's a little bit of a spread here, right? I mean, if we sort of look at where this is centrally concentrated, maybe it's about there or so, right? Then that's about what, -1.6 in RA, and it's going to -2 and maybe to -1.22, right? So pretty good spread this way, pretty good spread that way, but more or less they're moving all exactly in the same way. So I would say that all of those are probably part of the cluster. And so then what I would have to do, and not with GNU plot, but probably with a piece of software, go through the Gaia list and just correlate, right? Say, okay, this star has, you know, particular RA and DEC, and would be able to identify which one it is then. So very, very cool. I'm glad that worked out the way that it did. Yeah, it looks like we sort of made the first step in properly identifying cluster members. So that's pretty cool. That's pretty cool. All right. Well, I think I'm going to get out of here for today. Hope you enjoyed that a little bit. It's kind of fun to do on the fly science. So yeah, all right. I think I'm going to get out of here for now. Let me check the chat really quick. Make sure that there isn't any trouble. Okay, yeah. So if I want all rows, I can just remove true. Very, very true. Thanks, Tom. That is exactly true. I do yeah, there are so many ways of doing things, and that's the sign, right? That's the sign of good software, right? When there are multiple ways to achieving the same task, you've got a good piece of software. And they're probably using MySQL, right? Or some flavor of SQL, and so yeah, it's great to have options, right? So you can either do it Tom's way and just eliminate that whole thing in terms of top, or you can specify. Either way, right? Yeah, don't get me into query stuff because we'll be here the rest of the night. So, all right, I'm going to get out of here for now. Bobby, thanks for hanging in there. Hopefully it wasn't too annoying with all the slowness and stuff.
It's all good here.
Okay, cool. I sort of dominated things tonight because we got into it, and I was surprised. I don't expect much. So that was really, really, really cool to be able to see the clumping of those stars. So cheers. Cheers to Messier 25. All right. I'm going to get out of here. I will see you all on the spin tomorrow. One more spin of this little tiny planet. We'll all be back at 0 hours UTC. Make sure to hit the thumbs up if you haven't already, or hit the thumbs down, whichever you prefer. Make some comments if you like. I always like to see comments, and I'll definitely respond in some way. If you haven't subscribed yet, make sure to do that. And yeah, hope you enjoyed that. It's kind of fun, everybody's pretty excited about GAIA, and I am one of those that is, because it's just a lot. It's a lot of data, right? It's a lot of data, and it's very, very, very good data, meaning that it's extremely accurate and extremely precise. Now, I say that, and we'll find a paper somewhere saying, the GAIA, GAIA's off in some way and all of that, but you can actually read, the GAIA papers, and they do a pretty good analysis of how well they think, they're making all these measurements and stuff. And I think they're doing really, really well. So, all right, I'm going to get out of here for now. Take care, everybody, and I will see you in a little less than 23 hours. All right, peace and cheers. See ya. Bye.